Okay. Right now, okay. We'll begin. So first on the first question. Everyone, I'll give everyone about half a minute to a minute to try the question first. If you have an answer, please send it me through to me through the chat privately. Okay. I'll start explaining the question, and if anyone still has an answer, they could still send it to me through the chat. Okay, so we're given that we have four flowers in total. One flower has six petals, seven with the next one has eight, and then the last one has 11 petals. So in total, we have a total of six plus seven plus eight plus 11 petals in total. So that means we have a total of 32 petals. Since we have a total of 32 petals, now the question tells us that every time Kate wants to tear off a petal, she takes three flowers, any three flowers. For example, we take this one, and this one. She'll just take off one petal from each one. So then she'll take off a total of three petals because each flower we take off three each flower we take off one petal. So then off that one petal we take off a total of three petals. So now we have a total of 32 petals. So to maximize the amount we can take off, we'll just keep subtracting threes off of the 32 and so forth until we achieve a number and we cannot subtract three anymore unless we're going into a negative answer. So then 32 minus three, all the way on, we'll totally get 32 minus 30, which is 3 times 10. So 3 times 10, it's 30 is divisible by 3, it's 3 times 10. So then we can say she went through it 10 times, taking three petals off each of the 10 times. So then she'll take off a total of so we'll have a total of 2 petals remaining. And that's the smallest number of petals remain without her taking off any petals. So the answer is B. Any questions, anyone, before I move on to the next question? Okay, moving on then. For this lesson, I'll give you guys half a minute again just to like see and try the problem. If anyone has the answer, please send it through me to the chat. Okay, I'll start explaining this question. It is okay if you guys don't have an answer yet because I'll go through and you guys can check your answer with my work. All right, so we have a total of 2 pegs for each towel in the first figure, and then he will not Emil notices that he does not have enough pegs to hang up the tower that he will not have enough pegs and to hang up all the towels using 2 pegs for each one. So then he goes into figure 2. So for each towel, each 2 towels, we have 1 peg hanging up both of them, holding it into place in the sky. So so altogether he has 35 towels, and he used 35 towels, like each individual one of these, and we have 58 pegs. So the question is asking, so at the start he uses, so we could set up variables for this question. So we could say we have X amount of towels that you have 2 pegs for them, like these, they have 2 pegs. And then we can have 35 minus X amount that has one, that every 2 towels share a peg. Like see this one, they share a peg. So then we have a total, so because he like runs out halfway through, he realizes he won't have enough. So then he just switches immediately. So then we have a total of how many? We have a total of 58 pegs in total. So for each of the ones that have 2 pegs on them, we have 2x. We have 2x pegs there. And then we have to add on the remaining 35 minus x plus 1 peg. The reason why here it's plus 1 is because if we draw like a small diagram here, if we have 2 towels, then we'll obviously have 3 pegs, because we have to have one here holding it in place, another one here to hold it in place, and the final one holding it here in place. But then if we have 3 towels, then we'll have 4 pegs, because each of the towels have 1 peg they already have. And then to hold the last one in place so it doesn't fall down, we have to have 1 more peg. So that is why it's 35 minus x, and we have to add 1 extra peg on. And then we know that he has a total of 58 pegs on the line to hold all the towels. So if we expand this equation, then we have x plus 36 equals 58. And then so then we could solve for x, which x leaves us with 22. So then we know that he has 22 towels that are hang up with 2 pegs each. So then the answer is D. All right, moving on. If anyone has any questions, please, you're welcome to stop me and we could go over the question again. All right, next question. I'll give you guys like a minute to try. All right, so far I have 2 solutions, and I'll start going over the question. If anyone still has a solution, you're welcome to send it to me. All right, so we are given that we have 5 sparrows sitting on a branch as in the figure. Each sparrow chirps the same number of times the number of other sparrows it sees. So if we take a look at Charlie here, he could see 2 other sparrows right here. 1, 2. So he chirps twice. So then, and then one of the sparrows looks in the other direction. So if we have David here, he already sees 3 sparrows, but then when he turns around, he'll see 1 sparrow. So then we want to know which one, if we spin it around, will give us some more chirps. So then we will see. So then we look at every single bird first. If we look at Angel, he or she are the sparrow already sees 4, but if it turns around, it doesn't see anything. So that means it only had it can't be Angel, otherwise we'll go with Lester's. If we look at Bertha, it already sees 1 bird. So then if we make it turn around, it'll see 3 birds. So it will give 2 more birds. So it might be Bertha. If we look at Charlie, it already sees 2 birds. But then if we turn it around, it also sees 2 birds. So it gains nothing. It sees the same amount. With David, he sees 3 birds already. And then when he turns around, he only sees 1 bird here. So then he doesn't gain any. He loses it. He loses the amount of chirps. So he won't be it. And then like Angel, Eglio will also be the same because he also only sees 4 birds. And then when he turns around, he doesn't see anything because there is no bird here. So our answer is Bertha because when it turns around, it goes from seeing 1 to 3. So plus these 2 more chirps. So the answer is Bertha. B, Bertha. All right, moving on. I'll give everyone another minute or 2 to solve this question. All right, I'll start going over this question. So we have Anna, Bertha, Charlie, David, and Eliza that are baking cookies on Friday, Saturday, and Sunday. So then on over the 2 days, Anna made 24 cookies, Bertha made 25, Charlie made 26, David made 27, and Eliza made 28. And over the 2 days, one of them made twice as many cookies as they did on Friday. So that means if they made 3 cookies on Friday, then they made 6 cookies on Saturday. So and then one did 3 times as many, so they made 4 cookies on Friday. Then they made 12 cookies on Friday. So then on and on, one has 4 times, 5 times, and 6 times as many. So then we want to know who baked the most cookies on Friday. So then, so if we bake twice as many cookies, we have 3 cookies initially, and then we bake 6 cookies on Saturday for a total of 9 cookies. So then we have a total of 9 cookies. It looks like it's divisible by 3 because this is, if we put variables in for this one, then we have X cookies here, and then we have 2X cookies here. So then we have a total of 3X cookies over the 2 days added together. So then we will know that whoever made twice as many will have 3 times as many cookies as they had initially on Friday. And then the same with 3 times as many cookies on Saturday. So we have X cookies here again. Then they may have made 3X cookies for a total of 4X cookies. So then as we know, if they made twice as many cookies, then they'll have 3 times as many cookies. If they made 3 times as many on Friday, then they'll have 4 times as many cookies, and then 5, and then 6, and then we have 7. So then we have 24, 25, 26, 27, and 28. So then we want to know which one's divisible by 3, 4, 5, 6, and 7. So we know immediately that 25 is the only one out of these 5 that's divisible by 5. So we already matched up who made 4 times as many cookies on Friday. So we know that Bertha made 4 times as many cookies on Friday. So then on Friday, then she made only 5 cookies. So then we also know 28 is the only one divisible by 7 here. So then we know that Eliza made 7 times as many cookies initially. So then Eliza made a total of 4 cookies on Friday. The only one that made 6 times as many cookies on Friday. My bad. So then Eliza made 4 cookies initially on Friday. So then we want 27 is the only one that's evenly divisible by 3. So then we know that David made 3 times as many cookies on 2 times as many cookies on Friday than on Saturday. So that means David made initially 18 cookies, no, 9 cookies, my bad, 9 cookies on Friday. And then we know the 4 is the only one. So then we don't need to calculate the remaining ones anymore because we already know who made the most cookies. Because look, 28 can't be the, oh, my bad. I messed up here. Give me a second. Sorry about that. Okay. So then we have the remaining cookies to consider. So then we know that, wait, huh. Wait, okay, so twice as many cookies on Friday, twice 30 times as many on Saturday, and so on. So who made 26? Oh, Charlie made 26 cookies. So then we have Charlie made 26 cookies. So then, oh, I read the question. Give me a second. Okay, so sorry about that. All right, going over the question again, we know that one of them made twice as many cookies in total, not just on the second day, in total over. So then one of them has to be divisible by 2. The other one has to be divisible by 3, 4, 5, and 6. So we will do this. So we'll go over this again. Okay. So we know that 25 is divisible by 5. So then Daniel made 5. Berta made 5 cookies on Friday, and then we know that 28 is the one divisible by. So then we know 27 and 24 are divisible by 3, but then we don't know which one it is. But we could say that 27 is divisible by 3 is the one divided by 3 because 27 is only divisible by 3. It's only multiplied by 3. 27 is 3 times 3 times 3, which we could also write as 3 to the 3rd power, which most likely will not be tested. So we could just go forward. So then we know that David made initially 9 cookies. And then we know that 26 is the one divisible by 2. So then we know that Charlie made 13 cookies. And then we have 24 and 28. So 28 is not divisible by 6. This cannot work. So then we know that 24 must go to the 4. So then we know that Eliza made 7 cookies. And then the 6 goes to the 24. So then for a final of Anna makes 4 cookies. So then the one with the most is Charlie. So C is correct. And whoever said Charlie, that is correct. All right, next question. We're a little short of time, so we'll go through the questions a little more quickly. So here, I'll give you guys 20 seconds to go over it. Okay, so I'll talk about the question now. It's okay if you have not finished because we will go over it again. So then we have, okay, so we have the sum of the numbers around each hexagon will be 30. So know that the sum of each one is 30, and the sum of this one's also 30. So then we know that, so we know that these two numbers, we have them x and y. So then we know that 3 plus 6 plus 1 plus 2 plus x and y equals 30. So then we know that x plus y plus 12 equals 30. So then we know that x plus y equals 28. And then same thing with the other one. We can have this w, and z. So then we know that the sum of these four numbers, which is 23 plus w plus z, also equals 30. So w plus z plus 23 equals 30. So then w plus z equals 7. Sorry, my bad. This is 18. Okay. So then if we add these numbers, and then we look at the third hexagon we have here, this one. So then we have x plus y plus w plus z plus 1 plus our question mark value equals 30 again. So then we have 18 plus 7 plus 1 plus the question mark equals 30. So then we know that this value here, 18 plus 7 plus 1 equals 26. So our question mark value is at the end of 4. So then our answer is B. Okay, next question. I'll give you guys some time to work on it. I'll start explaining this question now. Okay, so there are a total of 20 apples, and we also have 20 pears in a box. So then Carl takes out 20 pieces of random fruit. We could say that he took out X apples, and then we also could say that he took out 20 minus X apples, because these two numbers will add up to 20 for the total 20 pieces of fruit he took out of the box. And then we know that Luca takes the rest of the amount. So then Luca takes 20 minus X apples, because there's initially 20 apples, and we take away X of them, we will have 20 minus X. And then he has the remaining pairs, which is 20 minus X. And then after simplifying this value, we have a total of X. He takes away X pairs. So then we'll just look at the answer choices. A, Carl got at least one pair. Well, we could say that he took none of the pairs and just took 20 apples. B, Carl got as many apples as pears. That's only if he got 10 apples and 10 pears. He could have got 9 apples and 11 pears, which then will destroy the possibility of that. C, Carl got as many apples as Luca. Well, we could look. Carl got 10 apples, got X apples. 20 minus X is the amount of apples that Luca got. Well, the only way for them to have the same number of apples is if they each got 10 and 10. But then we aren't sure if they both got 10 and 10. They could have got 11 or 9. So then if we look at answer choice D, Carl got as many pears as Luca got apples. We could look at that. See, they got 20 apples, and then they also got 20 minus X pairs. So then those values are equal. So then D must be the correct answer. E, Carl got as many pears as Luca. That's the same thing as the apples one. It might not be true. So then the answer choice for this question is D. Moving on. I'll give you guys a little more time to work on this. If anyone has any questions at any time, feel free to ask me, like by unmuting your mic and asking me, or just sending me a message. All right, I'll start explaining this question. So we have three pirates, and they're asked how many diamonds and coins their friend has. So then we know that each pirate answered truthfully. That means answered like in the right with the right answer to one of the questions. To this question, that how many coins he has, or to this question, how many diamonds he has. But then they lied on the other question, so we don't know if they answered true. So then their answers are written on the piece of paper right here. So then we're asked how many coins and diamonds he had. So then we know that they lied to what they lied on one question or they answered truthfully on the other one. So then we could look, hey, there's a suspicious two sevens here. So then we could say, if they were both lying here, then this one must have been the truth. But then 4 and 7, they are not the same number of diamonds. So that cannot be, so they cannot have lied. So these people must have told the truth. So then Graybeard must have 7 coins. And then for the 8, and then so then we know that this pirate lied. So then if he lied here, then he must have told the truth here about the six diamonds. So if they have 7 coins and 6 diamonds, if we add a number together, we have a total of 13 items, which goes with our answer C. All right, next question. Okay, I'll start explaining this question right now. So then in the most highest shelf, we have a total of 3 large ones, and we also have 4 small bottles. So then we have a total of 64 deciliters in total. And then for the second shelf, we have 3 small ones, 2 large ones, and we also have 2 medium ones. And again, this also is 64 deciliters. And then for the final third shelf, we have a total of 6 small ones, and we have 4 medium bottles. And again, this is also 64 deciliters. So then when we solve these, we have 3 system of equations now, and we want to solve these 3 systems. So then we could group 2 of them together, solve that one, and then find the third one. So then we could take a look at the first and second one. We could subtract this value. We have a total of 3 large and 4 small. We could take this one and subtract this one from the top one. So then if we use these two, then we will get 1 small plus 1 large minus 2 mediums, which is 64 liters, again, which is 0 deciliters. So we have a small and a large is equal to 2 medium bottles. So then we could bring it into the bottom one. So then the 4 medium ones here, we have 6 small, but then for each of the 4 medium, each 2 medium ones is a small and a large. So we have 2 more small ones from here. So we have a total of 8 small ones. And then we have 2 large ones because we have the 2 large here brought into here for a total of, again, 64 deciliters. So then we could look at the first and last one. They're very, very close to each other. So then we could just multiply this entire thing by 2, which gives us 6 large ones plus 8 small ones equals 2 times 64. And then we have the bottom one, and then we can multiply that whole value by 3. So we have 24 small ones plus 6 large ones equals 3 times 64. So then we could see they both have 6 large ones now. So then we can subtract the first one from the second one. So if we subtract this entire value here, we will get 16 small ones equals 64. So then we have the small ones has 4 deciliters. So then we plug this equation all the way back into the first one we have here, the 3 liters and 4 small liters. Then we'll have the L, the large value, equal to 16. So then we could plug both values into this equation here. And then we will have the medium value equals to 10. So then our answer is D, 10 deciliters. All right, next question. Please, if anyone solves this answer, please send me an answer. Okay, I will start answering this question. So we have a large cube which has a side length of 7. Hold on. Okay, we have a large cube that has a side length of 7. So each one of them is 7. So on each of the 6 faces, we have 2 diagonals that are drawn in red. So then we have the large cube that's cut up into smaller pieces. So we want to know how many cubes will have at least one red line drawn on them. So then if we look at one face first, if we draw every single cube, we will really just have every single cube that goes along the diagonal here. So then each diagonal will have 7 cubes because each side length is 7. So then each diagonal has 7 cubes. And then we have 2 diagonals for each face for a total of 14 total of 14 lines with the red line. But then we have to consider that we counted the one in the middle twice. So then we have to subtract 1 more for a total of 13 for each face. So then we have 6 faces, and then each one has 13 cubes that has a red line on it. So then we have a total of 78 cubes with a red line on it. So our answer is D here. Next question. Okay, I'll start explaining this question. So then we have 10 elves and trolls that are given a number between a token with a number between 1 and 10 written on it. They were asked what number was on their token, and all answered a number between 1 and 0. So if I had the token 3, I could have answered 3, or I could have answered 5. So then the sum of all the answers was 36. And then each troll told a lie, and each elf said a true thing. So if I were a troll and had a 3, I would have said 9 instead of 3, or 7. But an elf, if an elf had 5, it would have said 5. So then if we add up all the numbers between 1 through 10, we will get a sum of 55. But then the sum of the actual answers given was 36, which is different than 55 by 19. So then we'll see. So we want to minimize the amount of trolls. So then if a troll really had 9, and we want to minimize how many there were, then they would have said 1. And then if they had 8, they could have said 2. So then if we take 9 minus 1, which is 8, and then 8 minus 2, which is 6. So then this is 14 already. So we only need 5 more. And then so for each of the 5 more, so then we have 5 more. So if we have a 7 here, we could have said 3, but that wouldn't work. So then if we have a 7 here, if we were given a 7 here, they could have said 1 again. They could have said 2 again, so which have given the 5 that we needed here. So then the minimum amount of trolls would have been 3. All right, next question. I'll start explaining this question. So we have a triangle. We have a triangle here. Give me a sec. All right. So we have a triangle here with that is. Ooh, wait, hold on. All right. So we have a triangle here that has. So if we cut every single line in the midpoint, then we'll have the triangle, the small one with one with each side length equal to 1. So then if we tile the whole thing out, so then this will also be 1. And then so this side will also be 2, so then this side would be 2. So then that one would be 2, so then this one's also 2 because they all share the side here. So then we know that this side is 15, this side is 5. But then we already know that this is an equilateral triangle, so then the whole every side will also be 5. So then we don't need to solve for the other 2 sides. So we only need to solve for this side. Since all other sides will also be 5, then we just multiply by 3, and our answer is 15. All right, next question. Okay, I'll start explaining this question. So we have nine. So Riri the frog eats 5 spiders a day, or if she's very hungry, she eats 10 spiders a day. So then she ate 60 spiders on a total of 9 days. So we can say that X days she ate 5, and 9 minus X days she ate 10. So then we have a total of 5 times X plus 10 times 9 minus X. And then that's the amount of spiders she ate, which the question tells us was 60. So then if we expand this entire equation, then we have 90 minus 5x equals 60. So then if we solve that, we have x equals 6. Okay, and then 6 is the number of days she ate 5 on. So the number of days she was very hungry was 9 minus 6, which the answer is 3. All right, next question. All right, I'll start explaining this question. So we already know a dice. We have a dice here. And then each side has an odd number. So since each side has an odd number, we roll the dice now 3 times. So then we want to know which one cannot be the value of the sum. We don't have to try and guess every single one. There is a quick way. So we have an odd number plus an odd number. We know that gives us an even number. So then if we have an even number plus an odd number, it gives us another odd number. So then we know that if we have 3 odd numbers added together, we will have another odd number. All the answer choices except for 1 is an odd number. 20 is not an odd number, so it's impossible to have 3 odd numbers summed together equal 20. So our answer is 20. Next question. Okay, I'll start explaining this question. So we know that Jenna and Willie are throwing balls at 2 identical pyramids of 15 cans. Jet knocks down 6 cans with a total of 25 points, and Will knocks down 4 cans. We want to know how many points that Willie scored. So then we know that they have identical pyramids, meaning these two are the same thing. So then we can just fill in this square, this can, and this can, and if we draw in every single can from here on out, then we'll get the same thing. So then if we put in these numbers, so we know that we have one of them cans is 8, another can is 4, another can is 9, and then the only question remains, what is the can at the very top? So then we know that if Jet knocks down a total of 6 cans with 25 points, we know that 4 plus 3 plus 8 plus 2 plus 3, 4 plus 3 plus 8 plus 2 plus 3, which is a sum of 20. And then we want to know, and then since we already have a sum of 20 here, we know that Jet knocks down a total of 25 points. So we know the top can here is 5. Since the top can is 5, we add up these numbers, and then we know that it will knock down 4 cans. So we just add on the extra 5 to the cans that we filled into the drawing. And then that gives us an answer of 26. D. All right, next question. Okay, I'll start explaining this question. So that has two machines. One machine, if we put in one white token, it will give us 4 red tokens. So then, and then the other machine is that if we have one red token, it becomes 3 white tokens. And then Zev starts with 4 white tokens. So then we want to know after how many 11 exchanges, he has 31 tokens in total. And we want to know how many of those are red. So then we start off by putting all of these 4 white tokens into the red ones, so into the ones that make 1 white into 4 red. So after 4 exchanges, we have 16 red tokens. And then we could put some of these into the white ones, but we only have 7 more exchanges left. If we put all 7 exchanges into changing them, then we will have 9 red tokens left, and then we have 21 white tokens. But wait, this is 30 tokens. We wanted 31 tokens, so we have to change one of them. But now we could just change one of the white tokens into a red token, into 4 more red tokens, instead of changing a red token into a white token. So if that's too complicated, we'll do it this way. So then we use 6 changes, we will have 10 red tokens and 18 white tokens. We will still have 1 more exchange to do. So then if we put 1 more white token into a red token from here now, then we'll get 13 red tokens. Sorry, 14 red tokens and 17 white tokens, which then perfectly gives us 31 tokens in total. So then our answer is how many of those are red, which is 14, and that's our answer. All right, next question. I'll start explaining this question. We have 4 players. 1, 2, 3, and 4 players. And then they scored 20 goals in total. And one of them is Mike, our friend here. So then if we So then Mike is the one that scored the least amount of goals that we know of. So then the other people must have scored more than Mike. So then if we have Mike has some number of goals, we will have that Mike scored less than the other people. So then, but they all scored different amount of goals. So then if any of the other three players, we want to know that how much was the maximum number of goals that Mike have scored. So if they score the same amount, then they will have each a score of 5 goals. So then if each of these people have 5 goals, which we cannot, then the total number of goals that Mike have scored was have to be slightly less than that amount. So then we have to manage these numbers. So then we have to make them slightly bigger. So then we have 5, 6, and 7. Well, if we have these 5, 6, and 7, and we add these numbers together, then we will have a total of 18, which gives us about Mike has 2 score points, which is that's the smallest answer, which is probably not the right answer. So then we'll see about this question again. We'll try to do this again. So then if the other people have scored 4, 6, and 7, then Mike would have scored 3 goals. But then that's the maximum amount of goals that Mike could score. So the answer is B. Because if we make Mike score 4 goals, then this answer here would be 4. So we will have 4, 4, 5, and 7. But these two, Mike and the other person, scored the same amount, which is not possible because they all of them scored a different number of goals.
Bitch, no, you're so gross. He might think someone else typed it. He must have an answer.
Sorry about that. Give me a second. Okay. Let's just redo this question all over again. Okay, so let me just write this question again. Okay, so the other people's sorry about that. So the other 3 scored 20 in total. So then Mike scored an unknown amount, and then the other people scored 20 goals in total. So we want to maximize the amount of people. So that if they each scored 3, if they each scored 6 goals, then they would have 2 goals. They will still have 2 goals to need more. So then we have 6, 5, 7. We have 6, 7, and 7. But then these two are the same. So then we have to take 1, 7. We have to take 1 away. So then we will have too much here. We'll have 2. We can't use this amount because these two are the same. So then if we make this one 5, 7, and 9, and 8, my bad, 8, then we'll have 20 here. So then the answer is actually C. My bad about that question. Sorry about that. Okay, moving on. I'll explain this question now. Since most people still want me to keep reading, I'll keep explaining and going over problems. I'll keep going over for maybe an extra 15 more minutes. Okay. Okay. Okay, so this question we have 1, 2, 3, 4, and 5, and we want to put them into this box that has 5 places. So then we want to know that if a number, and we are given the requirements that if a number is below another number, we have to guarantee that it's greater than. So we have 3, if we have 2 here, then there has to be a 4 here. then the 4 has to be below, or it could be a 3 or a 5 because they have to be greater than the 2. So and the same, if it's right of a number, so we have 2 here, then we can have a 4 here, but we cannot have a 1. A 1 we cannot use there. So then we have and then we want to see how many ways we could put all the numbers into this arrangement. So if we start off, we have to have the 1 here, because if we have the 1 anywhere else, then the 1 has to be greater than another number, which cannot be done because 1 is the smallest number of the 5 numbers we are given here. So then we have the other choices. So for the 2, we can have 2 places to place it. We could place it here, or we could place it here. Because if we place it here, then we have to have some number that goes in between. But we only have 3, 4, and 5 remaining. So we put 3, 4, or 5 into the space, then it will be greater than the 2, not meeting the requirement. That has to be greater if it's below it. So then the 2 only could go into this square or this square. So then if we place the 2 at any of these 2 squares, then we will look at the next number, 3. So if we put the 3 anywhere, we could put the number 3 here, here, or here. So then we'll go into each case. So we've put the 3 here, but then we only have one way to put the 4 and the 5 here. So then that's one way for us. So, but then if we put the 3 here, we can have either the 4 here and the 5 here, or the 5, or we could have 5 here and 4 here. So then that gives us 2 more ways. So then that's a total of 3 ways we could have if we put the 2 here. But then if we move the 2 down here, it's the same thing. It's the same situation, just if we move the 2 down here, then we can, it's the same thing, it's just rotated. So we have the 3 here, we only have one way to put the 4 and 5, but if we have the 3 here, we have the 3 here, then we could put the 4 or 5 in either way. So then we have a total of 6 ways to put them all there. So the answer is D. All right, next question. Okay, I'll start explaining this question. So we have a bag, and inside the bags are only red and green marbles. So if we pick 5 marbles out of there, we will have a guaranteed 1 red. So for any 5 marbles we pick, we will have a guarantee of 1 red. If we pick 6 marbles, random 6 marbles out of there, we will have a guarantee of 1 green marble. So then what is the largest number of marbles each bag can contain? So then if we're guaranteed at least 1 red marble here, then we will want to say that we'll have 4 green marbles. Because if we have 2 red marbles in there, we will only have 3 green marbles. But we want to maximize the amount of number of marbles we can have. So we will want 4 green marbles here. But if we guarantee 1 green marble is 6, same idea. We want to maximize it. So we'll have 5 green marbles, 5 red marbles, my bad, 5 red marbles here. So then if we have 5 green marbles and 5 red marbles, we will add and we combine these two, then we'll have a total of 9 marbles, which is the maximum number of bags we could contain. Because if we have 2 red marbles, we guarantee ourselves 2 here, then we will have 3 green marbles, which will not work, which will make it even smaller. So it won't work out. So then our answer is C9. Next question. Okay, I'll start explaining this question. So we have every number such that every number at the bottom, if we add two numbers together, the next number will be here. So if we have 1 and 2 here, then the box above it will have 3. And we want to maximize the amount of odd numbers John could write. So we can start off by putting an odd number here, which will, and then an odd number, as we explained in one of the previous problems, is an even number plus an odd number. So then if we have, and then with the even number plus an odd number. So then with this even number, we can make it to maximize the amount of odd numbers we have. We'll say it's an odd number plus another odd number. But if it's an odd number here, then and this is an odd number, this must be an even number because even plus odd is an odd number. So then since this is an odd number and this is also an odd number, we want an odd number is always an even plus odd. We'll make this one an even number. So then we'll have two more odd numbers here. And then if this is an odd number and this is an even number, we want this must be also an odd number. So then if we count 1, 2, 3, 4, 5, 6, 7 odd numbers, we'll have a maximum amount of 7 odd numbers, which is our answer D. Next question. Okay, I'll start explaining this question. So Julia has 4 different color pencils. And then we want to use some of them or all of them. We could use 2 colors, 3 colors, how many colors we want into this map that has 4 countries. And then we know that any 2 countries that share a common border, like between country A and B here, they share this border right here. They cannot have the same color. So then we have 4 color pencils, 1, 2, 3, and 4. And we want to know how many ways we could color this island. So we could think of it this way. We first color the one that touches all 3 of them. So we have 4 ways to color this one from the original 4 colors. So once we used up this color, for example, then the other 3 that are also touching that one color cannot use that color again. So then we have 3 colors remaining for the first one here. So after we use this one, then this one cannot use the color that it used. So then it has 2 choices. But then this one, it can't use these 2. So since it can't use these 2, it will have 2 more choices because it can't use. So example, if this one uses red, then this one uses green. And if this one uses blue, it can't use red or blue, but it can still use green because these 2 countries aren't touching. So then this one has 2 more choices. And then if we multiply all these answers, if we multiply 4 times 3 times 2 times 2, we get an answer of 48, which is E. All right, next question. I'll start explaining this question. Okay, so we have four natural numbers that sum up to 39. Whoops. And then and then this product of two of those numbers is 80. So we have x, y, z, and w. Then we know that x times y is 80. And we also know that z times w, the other two numbers, is also 80. And we want to know which one's the largest number possible we could have. So then we first list out all the possible multiples of 80. We could have 1 times 80. We could have 2 times 40. 4 times 20. We have 5 times 16. And we also have 8 times 10. So then now looking at all these choices, we can immediately get rid of 1 times 80 and 2 times 40 because the sum of the four numbers must be 39, and 80 and 40 are automatically bigger than 39. So then we cannot use those two choices. Looking at the other two choices, 39 is an odd number. So then since 5 plus 16 is an odd number, we need to know, is it 4 plus 20 or 8 times plus 10? Which one's the other pair of numbers? Since 5 plus 16 is 21, and 39 minus 21, minus this number is 18, then we know the other choice must be 8 and 10. So then if we know it's 8 and 10, 5 and 16, then the biggest number possible is 16 here, which is our answer of C. All right, we'll go over 3 more questions tonight, and then I'll end the seminar. Okay, I'll start explaining this question. All right, so Jane brought some books. She bought 3 books in total, and then after she bought the first book, and she paid half of her money and $1 more. Second book, half of the remaining money and $2 more, and for the last book, half of her remaining money and $3 more, and she ends up with no money left. So for this question, we work backwards, meaning that if we have $0 after she spends everything, she spent $3 and half of her money. So then with the $3 more, she has $3. So then before she buys the last book cost $6. So she had $6 at the start before she bought the last book. And then for the next book, like the same thing, we add 3 and then we times this value by 2 to get the next book's value. So then 6 is the amount of plus $2 more, and then we multiply this value by 2 again because she paid half of that much. So then she gets $16. So it's then before she bought the second book and the third book, she had $16. So then now we have to find the first book. So we do it again, 16 plus 1 for half of her money again, and then we multiply by 2 to find the original amount of money she had, which is a $34. So the answer is C, 34. All right, next one. I'll start going over this question. This is a pretty tricky question in my opinion. All right, so we have a number 100. And it's multiplied, we either have multiplied by 2 or we multiply by 3. And then from each result, we either plus 1 or plus 2, and then we divide the final result by 3 or 4. And then we note that the final number is a number. It's not a fraction, not negative, it's just a number. So then we know that it has to be divided by the final number, either plus 1 or plus 2 from here, or times 3 plus 1, or times 3 plus 2, must be divisible by 3 or 4. So here comes the trick. We know that 100 is already divisible by 4. And if we multiply by 2 or 3, it's still divisible by 4. And then we know that a multiple of 4, if we add 1 to it, it will no longer be divisible by 4. We could test by using a smaller one. We have 4 originally, and then we plus 1 onto it, then we get 5. And 5 is not divisible by 4. The same thing with plus 2. 4 plus 2 equals 6. It might be still divisible by 2, but it's not divisible by 4, which is what we want, divisible by 3 or 4. So then now we can know that we can't divide by 3, we can't divide it by 4. So we only can divide by 3. But then if we have divisible by 3, then we can't, now we know that we can't, since we can't, now we can know using the logic of dividing by 4, we can't go down the path of times 3 because 300 is divisible by 3. And then if we add 1 or add 2, it's not going to be divisible by 3 anymore. So then we know we can't go down this path. So we only could do 100 times 2 plus 1, or 100 plus times 2 plus 2. So then we can just calculate each value. So then we eventually end up with 201 or 203, 202. We find out that 202 is not divisible by 3. And then when we divide 201 by 3, we get 67, which is fortunately one of the answer choices C. So then the answer for this question is 67, which is C. All right, last question of the night, and I'll end the seminar. Let's see how many people could get this question. I'll give everyone maybe half a minute more because this is the last question of the night. All right, I'll go over the question now. All right, so we have this weird shape thing. So we know that we place 3, 4, 5, 6, 7, 8, 9 into each of these circles. And then we know that if we have each one connected now, then we know that the ones in the straight lines, the ones that we sum up into straight lines, for example, this one, will be the same as the other three that are also summed up in each of these lines, such as this one and this one. Okay, so then we want to know what are the possible amount of values we could put into this middle circle. So then let's think about this question. So then if we put, the most obvious choice would be to put 6 in here, because if we put 6, then we could just put 3, 9, the ones that are opposite, and 4, 8, and 5, 7 into the other circles. Yes, this is one of the ways we could do it. So we know that 6 works now. But then we want to know, are there chances that there's another way to put it in there? So then let's think. So we could put the smallest one into there. We could put 3. If we put 3 into there now, if we put 3 into there, then we could do the same thing as we did before. We put the largest and the smallest one into there. So we could put 4 and 9. And then we do 5, 8, 6, 7 into the remaining ones. And yes, that works again. So then we know that 3 works. So then we could do the same with the largest number. If we put 9 in here, then we have 8 and 8, 3, 4, 5, 6, 7, 8. We could do the same thing, put the largest and the smallest into opposite ones, and then we just rotate it around with like each one getting smaller and larger. So then we'll have 5, 6, 4, 7, and 3, 8. So then 9 works, but then we want to know, do any of the numbers in the middle, 4, 5, and 7, 8 work? So if we put the 4 in the middle, if we put a 4 in the middle, and we put the opposite ones into there, we have 3 and 9, 5 and 8, and 6 and 7. Well, these here, they add up to 17. Wait, nope, my bad. They add up to 17. This one also adds up to 17. But then this line, it adds up only to 16. It's because the 4 is in the middle here. If we take out the middle number, then these aren't connected anymore. So since these are connected, they're off by 2, then this value will be off by 1 here. The same as if we take a 5 here. If we take the 5 instead here, if we take a 5 here instead, then this value and this value are off by 2. So then one of the values will be off by 1 here. So then the same thing if we take a 7 or an 8. So then we know the only 3 values that are possible is 6, 3, and 9. So then we add those numbers together, we get a total of 18, and that is our final answer for the question of the night. All right, so thank you everyone for coming out and doing these questions with us. And that will be it for tonight.